Hello, my name is Jonathan Apostle, and this is my 5th lab report for Physics 2211. So for the purpose of this lab, I decided to start out by looking at two different balls in a computational system. The first one was elastic, and therefore it would bounce back up to the original height. The other one was like more what you would expect to see in reality, and instead of bouncing back to the original height, energy was lost due to things like sound, heat, and compression, and as a result, it would have less velocity when coming back up. So for the fundamental principles, I'll be looking at Newton's second law along with the kinematic equations to show the velocity of the ball. Additionally, I will seek to apply collisions and kinetic energy. So for my main result, I did find that the ball, which loses energy, did take a shorter amount of time to fall and stop bouncing eventually. And just a quick side note, this lab is entirely computational and there will not be a physical experimental portion. Also, since this is the final lab, there are no what if or what does it mean questions. Here's some main physics ideas, more specifically the equations. First off, I needed to use kinematics. This was mainly to show the velocity of the system, which would be the ball. Also, the kinetic energy principle is important because I can calculate the energy at each bounce. Finally, I need to use collisions, more specifically the coefficient of restitution, and this basically just shows how much energy is not lost to things like sound, heat, or the change in the structure of the ball. And again, this is the one that's not elastic. So here's just a quick drawing of what I did. So in the model, I have the ball and I drop it so there's no initial velocity. And then it's going to hit the ground and then it's going to release kinetic energy. And then this I can use to show how much velocity is conserved or lost in the system. So for my model, the system is going to be the ball, and then everything else is going to be the surroundings, which includes the floor and earth. So here are my initial conditions. For starters, the height of the drop is 1 meter, and then the mass of the ball is going to be 1 kilogram. And this is important because it really made my calculations more simplistic, and this is mainly just for GlowScript. So for my GlowScript code, my first step is to have a while loop. This is because for an elastic collision, if I don't have this, then the ball's just going to bounce forever. Also, I can then update the position, and then I'm going to check to see if the ball hits the ground, and then if it does, I can change the velocity as necessary, and this mainly takes into factor that restitution, which is expressed as E. And then I can update the velocity after that, and then I can just change the time. So I'm going to include my code in the description of this video. However, I decided to just show you how this works. So right here, I have a variable which basically tells the number of bounces that you have. So I'm going to do 8 here. And as you see, it's going to bounce 8 times, and since it's elastic, it's going to return to the same height and also have the same energy on impact. So for my results, as seen in the graph, I was able to conclude first that in the model which accounted for energy lost, the time for each bounce is shorter, and therefore there was a lower speed per bounce. Also, I was able to prove that it had less energy per bounce. So as you can see, the elastic and the inelastic, they follow a relatively similar pattern. However, the inelastic one, it eventually tapers off, and therefore it took less time to bounce because it lost some energy. However, there is a clear issue and a limitation within my model, and this is that it doesn't take into account any compression within the system. Instead, the velocity just rapidly jumps up from a negative to a positive direction as seen in that graph. And in reality, this isn't true, and the rate takes a little bit longer. Yes, it's still quick, however, it isn't instantaneous.